Hello, my name is Josh Naddor, and today we're going to be talking about the definition of the derivative. So the following definition we're going to be using for the definition of the derivative is this right here on this whiteboard, right here at the top. We have the limit as h approaches 0 for f of x plus h minus f of x, all divided by h. So the example I'm going to be using for this problem is 2x squared plus 5x plus 7. So before we go ahead and evaluate this, we should talk about some of the common mistakes that happen with this kind of a problem. We have to make sure we aren't evaluating the limit too early. It might seem a little tempting to just go ahead and evaluate the limit right away, because then we could have a 0 in the denominator. And since in math we're never, ever allowed to divide by 0, then you just say, oh, it's undefined. And if it's undefined, that means the limit does not exist, right? Nope, not really. Especially in this example. Let's talk about another common mistake. Function composition, not everybody's strong suit. It's okay. So let's talk about for this one, fx plus h. We just add an h on the end, right? Nope. Again, not that simple. f of x plus h is not going to be equal to 2x squared plus 5x plus 7 plus h. It is going to be equal to something else though. Let's talk about how we can find that something else. Switch whiteboards real quickly. And ta-da! I know this might seem like a lot, but it's not too bad. So let's talk about what we have here. So in the top we have f of x written a little bit differently. I wrote it having parentheses around each of my x's so it's more obvious what I'm going to be composing. So f of x is now going to be equal to 2 times parentheses x close parentheses squared plus 5 open parentheses x close parentheses plus 7. So that means f of x plus h is going to be equal to 2 open parentheses x plus h close parentheses squared plus 5 open parentheses x plus h close parentheses plus 7. And we can simplify that all out to see that that is equal to 2x squared plus 4xh plus 2h squared plus 5x plus 5h plus 7. I don't know about you, that was a mouthful. Alright, so now we're finally over here. We can actually start solving the problem. So we have the limit as h approaches 0 for 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 7 minus parentheses 2x squared plus 5x plus 7. And then we close the parentheses, and that's all being divided by h. So in the purpose of saving time, I'm going to go ahead and say everything in green is probably going to be staying. Everything in red, that's going to cancel out with something. So we have right here 2x squared. Let's see where that has a partner that's canceling out. Oh, right here, minus 2x squared. So that's going to cancel out. 5x, minus 5x. Anything else? 7. Okay, all you guys are going goodbye. You got voted off the island. I don't think we've ever had 6 people get voted off before, but whatever. So then we have the limit as h approaches 0 for 4xh plus 2h squared plus 5h all over h. And I should go ahead and evaluate the limit right now, right? Nope, still not good enough. Why don't I try factoring out an h right here? So, oh, it's in red. That might be an indicator. So if I factor out an h, I have 4x plus 2h plus 5 times h, all divided by h. And again, we're still evaluating the limit. So then I can cancel out these two h's. Goodbye. So then I have the limit as h approaches 0 of 4x plus 2h plus 5. And I probably need to do something else before I evaluate, right? No, we actually can go ahead and evaluate this limit right now. So I'm going to go ahead and do that. Plug in 0 for h, so I get 4x plus 5. Okay, we're done. Woohoo, yay, and the people rejoice. I hope this video was informative. I also hope you have a great day. Thank you.